So in this lesson, we're going to take a look at writing an absolute value that has a quadratic inside of it as a piecewise function. So first of all, we're going to need most likely 3 rule lines. So what you can do is add a rule right here. And so we get our 3 rule definition piecewise function. Now, the reason why we're going to need 3 rules is because the way parabolas work is we either have a positive a value happy parabola that looks like this, or we have a negative a value sad parabola that looks like this. In either case, we're going to be seeing how they interact with the x-axis, because if they cross the x-axis and we're trying to make an absolute value version of the quadratic, we need to take any negative region, which in these drawings that I sketched would be right here, or here, or here. Those negative regions need to become positive. The absolute value symbol basically makes your graph reflect any negative region. So I'm going to take this negative curve and I need to effectively turn it up. And the way that we do that is we multiply the function that's on the inside, the quadratic that's inside of there, by a negative 1. We negate it. And then over here on each side, we're going to need to negate here and here. And the way we do that is through a 3-rule piecewise function. So now that we've got the background of what we're doing visualized here, our job is to figure out when do these transition moments happen. And the when they happen is when we're on the x-axis. We're on the x-axis when y is equal to 0. So in both of these cases, whether we have a positive a value or negative a value, we need to know when is this function on the inside equal to 0. So we take it off to the side and write x squared plus x minus 2 equal to 0. And we go through our math 2 algebra process of finding the zeros. And a lot of you learned the magic X process. The magic X takes the A and C value, the 1 times negative 2, and puts that up top. And then the middle, the B value, the 1 on the bottom. And then you figure out your magic numbers, the products of 2 that add to be 1. And that would be 2 and a negative 1. So that we can factor this to be X plus 2 and X minus 1 equal to 0. So now all of a sudden we're doing some higher level factoring and solving skills. We use the zero product property, write x plus 2 equal to 0 and solve that equation. You write x minus 1 equal to 0 and solve that equation, because products equal to 0, each product can be separately solved. So x equals negative 2 is what the left side produces, and x equals positive 1 is what the right side produces. Now what those numbers are is where these parabolas, or this parabola specifically, it's a positive a value parabola. This is where this hits the x-axis. We hit the x-axis at negative 2 and then again at 1. So our rule here is going to be split up into 3 places. So on the number line at negative 2, we have to define what happens over here. And then at 1, we have to define what happens between negative 2 and 1 and what happens at 1. Well, this is a happy face parabola. So what that means is that everything to the left of negative 2 is already positive the way it's supposed to be. So left of negative 2, the way that you write that is you say x less than negative 2. That's my rule here, starting left to right. We're going to write x less than negative 2. That rule is already correct because this parabola is heading up in its positive. So what I do with that is I just write the parabola, the function, the quadratic that's in here, the way it is. X squared plus x minus 2. The middle region from negative 2 to 1, the way that I write between negative 2 and 1 is I write negative 2 is less than x and is less than 1. That rule, that piece goes here. Negative 2 is less than x, is less than 1. That's defining this region right here. Now, the only issue I'm going to have is At -2, I either need to say it's equal to and uses this first rule or equal to and uses the second rule. And just for this instance, I'm going to go ahead and put the equal to right there on the -2 on this second rule. You have to define one of them to be equivalent. And then what I need to do is this region needs to reflect up. This middle region, because right now it's a happy parabola, it goes below the x-axis. I need it to shoot up. So the way that I do that is I just multiply my function, my f of x piece, the inside piece, not the absolute value part, by a negative. And so the easiest way to do that is you write the function the way that it was given, x squared plus x minus 2, throw parentheses around it, and put a negative sign in front of it. And now I have effectively turned that parabola upside down so that it bounces up and is all positive. I only have one last issue, and that is everything bigger than 1. So everything to the right of 1, the way to write that with the inequality symbol is x is greater than 1. And so I write x is greater than 1 here as my final rule. And again, one of these has to be equal, either this one up in the middle or this one down below, and I'll just write it down below. It doesn't matter as long as you choose one of them. And then this piece of the quadratic is already in the right above the x-axis. So I'm going to write the quadratic the way that it is, x squared plus x minus 2. And those three broken up pieces and these rules defining it as such gives you a function that looks like this. And that's what an absolute value parabola quadratic looks like. It's kind of a W sort of ish graph. Now in my next example, we're going to take a look at what happens with a negative a value, and we're going to have to reflect these ends and leave the middle part the same. And all that's going to affect is what's happening here, which ones get negated. We're still going to have a very similar process with the rule. So let's take a look at the second example. All right, in this example, we see that we have a negative a value, which means this will be a sad face parabola. So when you have negative a values, you get this situation here where I'm going to reflect the ends. So both ends, this corner and this arrow, both of them are going to need to be reflected up. So our job is to identify when does this touch the x-axis. So to figure that out, I set the quadratic that's inside, negative x squared plus 10x minus 21 equal to 0. And what I'm going to do is factor and solve it, which is going to allow me to have my 3 intervals. Now, looking back over here at my function, remember we need to add a rule because we need 3 separate rules for this function. Our job is just to figure out where's the transitions, and that part is coming out from factoring and solving. But before I factor and solve, I want to make sure that I wrote this right, which I did not. I put a plus sign. That needs to be a negative sign here. So same thing, negative, negative, negative. And so now I'm going to get rid of those negative signs by changing them all to be positive. I do that by multiplying this whole thing and distributing a -1 across there. So that's going to give me x squared plus 10x plus 21 equal to 0. And then I go through and factor with my magic x. And the magic takes the 1 that's here and the 21 here and multiplies them to get 21 on top and 10 on the bottom. And I have to figure out what multiplies to be 21 and adds to be 10. That should be 7 and 3. So I factor this to be x plus 7, x plus 3 equals 0. And then I use the zero product property, set each of those equal to 0, x plus 7 equals 0, x plus 3 equals 0, and continue to solve. I get x equals -7 and x equals -3. That means my first x-intercept here was -7, and the second x-intercept was -3. So now I start to process what my intervals are. So everything left of -7 would be written as x less than -7. Everything between these two would be written as -7 less than x less than -3. And everything to the right of this would be x is greater than -3. So I'm going to take those 3 intervals and write them in order down below. X is less than. I'm going to throw the equal sign on one of them. I'm going to go ahead and go with the -7 at the first line. And that means the second one's going to be -7 less than, but not equal to, because I chose the equal to on the first one, x, and then less than, and I'll go ahead and make that one equal to -3. I'm just mixing it up because I want you to see that it doesn't matter. As long as one of them gets it, you've got it written properly. And then finally, x is greater than -3 are my three intervals. So now what I do is I just choose the right segment to leave alone. That would be this middle segment. It is already positive, which means the middle segment is written correctly the way it stands. I have -x squared minus 10x minus 21 is already written correctly for this middle interval. The first and the last intervals need to be negated. I need these negatives to go up like this, so that ultimately what I get is a graph that looks like this W-ish quadratic bent function. So I negate by multiplying a negative to this quadratic function. I'm not actually going to distribute. I'm going to leave it alone. You could distribute if you liked, but I'm just going to write it the way it is with parentheses. So negative x squared minus 10x minus 21 with parentheses. So that way the first and the last, you can see, got a negation. So they reflect up over the x-axis, and the middle region was left alone across these three intervals. In this next example, we see just a different variation of how we find the solutions. This inner quadratic function doesn't have a c value, so the solving part is different. We're still going to have a positive a value experience where it's a happy parabola. And so we want to recognize that it's the middle portion that's going to be reflected up. So just like before, we're going to add a rule, and then we're going to factor after setting the middle part equal to 0. So x squared plus 6x equals 0. We're going to factor the x because this is not requiring, there's no c value, so this is not a magic x type of factoring. This is a greatest common factoring process. So factor out an x, and when I do that, I have x plus 6 left equal to 0. And then we go ahead and set each of these equal to 0 using the zero product property. So we have x equals 0, and then x plus 6 equal to 0. So when I solve, this part is already done. That means my first x, or one of the two x's, is 0. And then this one, when I solve, I'm going to x equals -6. And then putting them in the right order, which is why I caught myself when I said the first x is 0. The first x is actually -6, and the second x is 0. So my two intervals, my three intervals, are everything left of -6, which is written as x less than -6. This one in the middle is going to be -6 less than x less than 0. And this one to the right is going to be x bigger than 0. I just have to make sure that I put some equivalency statements in there. X less than -6. I'm going to have x less than or equal to x, or sorry, I meant to say the 0 there, and then on this side, the -6. Geez, I'm going to erase that. -6 less than or equal to x, and then less than or equal to 0, which leaves me to x is bigger than 0 for the last rule. So on this particular graph, because it's a happy face parabola, the first and the last intervals are positive already, so we leave them alone, and we write x squared plus 6x. The last interval is also x squared plus 6x. And the middle one just needs to be negated. So I multiply this by a negative value. So I make it negative x squared plus 6x. And that should be the appropriate piecewise rewriting of that absolute value quadratic.